Okay. So we had started there on Tuesday. Making or constructing a histogram. Making a histogram. Check my Zoom people to see who's here and who's not. So I'm going to be taking attendance when you're on Zoom as well. Okay? That's MC's policy. You have to be in class. Now, when I said the word histogram, what two words did I say needed to pop in your head? Bar graph. Okay. And then you already had step one written in your notes. What was step one? What did it say you had to have? You must have a frequency distribution table. Now, let me kind of tell you, now we're going to try something. I'm praying to Jesus it works. Okay, now, for my Zoom people. Now, what I want to make sure you understand is this. We talked about last time that sometimes when you give people numbers, they just kind of glaze over. But sometimes when you give them a graph, it's better for them. Now, let me see if I can do this with them. Do this with you. All right. I'm going to try to share the screen with everybody. We'll see if it works. All right. Let's hope. These are the COVID numbers from the Mississippi Department of Health as of today. Okay, now let me go to my camera control and see if I can figure out which one will show it. All right, two wheel. Let me see if I can do it for them where they can see it. All right, people on Zoom, give me a thumbs up. Can y'all see that table? Y'all good? All right, now I want y'all to notice. These are the numbers for the total cases in the counties in Mississippi. Like as of today, Adams has 751 cases of COVID since they started counting in March. Okay? If you jump down here, you know, you can start looking like my parents live in Talbot County. They're actually, I have relatives that are part of that 576. My parents, my brother are three of those numbers. Okay? So this is the Mississippi Department of Health. So you can go through and look. You can see how many cases are in your county. You can see how many have died of COVID in your county. You can see, now LTC means like nursing homes, long-term care facilities. So they break it up into, so 12 of the 31 deaths in Adams County came from nursing homes. So you can scroll through, but you see how these numbers just tend to overwhelm you? All right, you're in Hinds County right now. Hinds County's got 6,357 people since March have had COVID. All right, 137 people in Hinds County have died of COVID. So you can scroll down and these numbers change much daily. So I tend to check the website to see what's happening where I live. Is everybody with me? Or where I'm going. Now, but that overwhelms people. But look what is easier sometimes. Look here. Let's look at this one. All right. Let's see if we can do it. Every time I touch this, all right. Zoom in for the Zoom people. All right. Now, for y'all, I want you to look. Do you see that somehow looking at bars is easier than looking at numbers? Now, what's a little bit hard to see from the back of the room is this bar is for people that are less than 18 years old. This is the bar in Mississippi that are 18 to 29. Where do you fit? Don't you fit here? These are people that are in their 30s, these are their 40s, these are the 50s, the 60s, the 70s, the 80s, and the 90s. So they tell you that the blue bar are the cases, the red bars are the deaths. So tell me something that you notice when you're looking at the bars.
The deaths get worse by age.
But who has it more? You do. So the group at the highest risk for just getting it appears to be people that are what? 18 to 29. That's who's got it more. But out of 17,000, there are 17,336 confirmed positive cases with people that are 18 to 29. If you're in your 70s, there's 5,406. That's less than a third. But the difference, like you said, is only 17 people in your age category have died. Whereas in the 70s, 634 of them have died. So this idea that somebody your age isn't going to catch COVID is ridiculous. You're catching it more than anybody else. The difference is you're not what?
Afraid to die.
You're probably not going to die. Now, 17 people did, but chances are what? You're good. But now your grandmother over here is in a heap of trouble. See, I freaked out because my parents are here. But that's a quick, in other words, people tend to look at graphs very quickly. You're not going to scroll through the numbers. So a histogram, now this is a type of histogram, but a histogram is what kind of graph? A bar graph. This is like a double bar graph, and sometimes double bar graphs are really good, like this one, because you can compare some things. So they're different things. Catching it's different than dying from it. Okay? So that's the reason that, like, we're real particular. That's the reason that we're very particular at MC about what's happening. So we're going to learn to make some of those tables, because if I'm going to present data, people will look at a bar graph way more than they'll look at a whole list of what? Of numbers. Now, we're going a lot of times in here, because we're doing data, we're going to talk about COVID a fair bit, because that's the reason you got that mask on. So just 2 seconds of not math, but all I did all summer was look at research for COVID for MC. So I'm very aware that your age population, your age group gets it more. When I say gets it more, I mean test positive for it. We don't know if they get it more. Does that make sense? But you're testing positive more. What are some possible explanations for that?
We're going out a lot more.
Yeah, probably it's the fact, it's probably not you're more susceptible. It's that, you know, I pretty much locked my parents in their house. You see what I'm saying? Like, didn't help, but I tried. You know what I'm saying? Like, I don't need you to go out. So people my age are a lot more careful because we're more likely to die than you are. Okay? The problem is, though, and also what's true, in my stats class in the spring, when y'all had to shut down for spring break, they were doing all this for me. What they found out from where I sent them was the other issue is your age group tends to be asymptomatic even more than my age group. So you really don't show symptoms as much as people my age sometimes show symptoms. Now that's a generalization. Is it true for everybody? What? Do you know what the number one symptom for somebody your age is? The number one, the only symptom that's pretty general about your age is you lose your sense of taste or smell. So you need to start noticing that. You know, I laughingly said, I started laughing at MC. I said, what I need to do is get some markers that are scented and like do this when you walk in the room instead of showing me your campus clear. I'm like, what scent is this, Tyler? You know what I'm saying? What scent is it? You know what I'm saying? And then change it so you can just hear apple and say apple. Okay? But you need to notice that. Like if you can't smell the scented candle in your room or you walk in the camp and it's not, you need to notice that because that's the #1 symptom that people your age show is a change in their taste or their smell. So start noticing that. And again, where did I find that from? I went and looked at studies. See, I went and did statistics all summer long. Why are you wearing that mask? It comes from studies. It's not just because Dr. Fauci said that'd be a good idea. All right? They've done studies, and one of the studies I found from Korea, hamsters can get COVID. Who knew? Okay? So they literally took a cage of hamsters that were infected with COVID, and then they had a cage of healthy hamsters, and they blew a fan. And looked at how many of the healthy hamsters got COVID. And it was a very high rate in the 60s. Then they used a mask. Now I went, we put a mask on a hamster? No, they did not put a mask on a hamster. They put a mask on the cage. They put a mask on the healthy hamster cage and blew the fan. And it cut the rate. Now, it didn't cut it by as much as I wanted it cut. Is everybody with me? But it did cut it between a fourth and a third. So that would mean I'm wearing my mask and the sick person what? Isn't. So does it help to wear a mask even if the sick person doesn't have on a mask? What? Yeah, it helps. Then they took that mask off, got some new animals that were healthy. You know, they already, poor, sorry, gave you COVID. Okay, now, then they went and got some more healthy hamsters, and they still have sick. And they put the mask around the cage of of the hamsters that were infected. Now the rate dropped 2/3. So what that means is, that's if I'm not wearing a mask and the sick person what? Is wearing a mask. But when they're both wearing masks, you see how the rate even goes up? So people will say masks don't work. That's not true. Masks do work. I've got studies that show masks work. Do they work all the time perfectly? No. I didn't say it cut the rate down to nothing. I said it cut the rate. Is everybody with me? The reason you're 6 feet apart is the same reason. I've got studies that say, now the World Health Organization says 3 feet. The CDC, that's the the World Health Organization is global. The CDC is like the American, that's the American Center for Disease Control. They say 6. Why do they say 6 when WHO says 3? Because it cuts the rate in half. Every time you double the distance, it goes down. Well, it'd be perfect if you were in the room alone. You see what I'm saying? But we can't do that. So I'm saying those numbers they're picking are numbers based on studies. They're not just random numbers. And again, it's not perfect. The problem is that COVID is a virus, and viruses mutate. Which means what was true in March with that version may not be exactly true in September with this version. Is everybody with me? So it appears that the virus has mutated some. So now the virus seems to be, but again, we don't know, is more contagious and less deadly, which I'll take. All right? But so when they say, well, why should I wear a mask? You're wearing a mask for your protection, but even more for what? Somebody else's protection. And if I'm going to be a Christian, if the Bible says, greater will have it been to lay down his life, all I'm asking you to do is wear a mask. So be kind. All right, now into the mini sermon. All right, now you got to have a frequency table. Now, here's the second thing that you're going to have to do once you have that frequency table. All right? What you're going to do is this. You're going to basically have to find something on a histogram. Here's what you're going to find. You're going to place the class boundaries on a horizontal scale. on the horizontal scale. All right, place the class boundaries on the horizontal scale. Now, I don't say x-axis. You can think x-axis. I'll explain in a minute why I'm not saying x-axis. You're going to put the frequencies on the vertical axis. Okay, you're going to put the frequencies on the vertical axis. And then write yourself a note. You must start with 0. And I'll show you why in a second. Now, did I say the horizontal scale had to start with 0? I didn't, did I? But the vertical scale, what? Does. And when we do one, you'll see why. And then all you're going to do is draw a bar to a height that corresponds to the frequency. All right. So you write those steps down. Hopefully you can read them. My writing's not great. Okay. And then we're going to do one. So step 1 is you got to have a frequency distribution table. Step 2 is now you got to go find those class boundaries. That's why you had to find it for homework. All right. Then those boundaries go on your horizontal scale and the frequencies go on the vertical scale. And then you simply draw those bars. So let's kind of go do one. All right, so have your steps beside you because for the Zoom people, I'm going to have to switch to this other board. So y'all need your notes next to you. Okay. Now, all right, so suppose you have a table that looks like this. Let's do something simple. And the directions say draw a histogram. Okay? So as soon as it says draw a histogram, what 2 words pop in your head and remind you? Bar graph. I'm going to say that over and over. You're going to hear it yourself. Okay? Now, step 1 is you have to have a frequency table. Do I have a frequency table? Now, what if you didn't have one? What would you have to do? Make one. So that's why you learned last night to make one. Okay? So let's go do the steps. So the first step is on some kind of horizontal scale, I've got to place the class boundary. So what does that mean you have to do right now? All right, so you got a calculator, so go find me all those boundaries. All right, so we got to find these class boundaries. Now let's review how we do that. If you want to find class boundaries, you take the end of class 1 and what? The beginning of class 2, right? What do you do with those 2 numbers?
Right.
Subtract, all right? So 15 minus 14 gives me 1. Now, what's the next thing I do? What do I do with that difference? I take that answer and do what? Divide by 2. So 1 divided by 2 gives me 5/10 or a half. Now, what do I do with this answer and these upper limits? Yeah. So when you add 14 to 5/10, I get 14.5. Everybody with me? When I add 5/10 to 19, I get 19 and 5/10. When I add 5/10 to 24, I get 24 and 5/10 and 29 and 5/10. Now, what do I do with this answer and these lower limits? Subtract, all right, what's 10 minus 5/10? All right, 9 and 5/10. What's 15 minus that 5/10? What's that gonna get?
14.5.
All right, so I get 14 and 5/10, and 19 and 5/10 if I can subtract, and 24 and 5/10. So those red numbers are my boundaries. Everybody okay? Now, if you've done it correctly, what do you notice about this upper boundary and this lower boundary? They better be the same. If they're not, I'm in trouble. Now, these numbers get put on a horizontal scale. So what's my first boundary? 14 and 5/10, is that right? I mean, excuse me, 9 and 5/10. What's my next one? 14 and 5/10. Now, I'm not gonna make you get a ruler unless it's really bad. But this is supposed to be to scale. So if these are about that far apart, I need these to be about the same distance. Everybody with me? So what's my next one? 19 and 5/10 and what? 24 and 5/10 and what? 29 and 5/10. So that's what I mean by put those boundaries on the horizontal scale. Now, let me ask you this. Look at the table, the original table. What's the class width on this table? 5. How far is this boundary from that boundary? 5. So the boundaries better be the same distance apart as the widths, or again, you made a mistake. So it's kind of a check. So see, every one of these should be about 5 apart. Excuse me. So that's what we got to have it like that. Now, then I've got a vertical scale. Now, what goes on this vertical scale? The frequency. Okay. Now, what's my biggest frequency? 10. So this thing's got to start with what? 0, right? Now, I don't care if you go up by, if I don't see any numbers, I'm going to assume that you went up by 1. Everybody with me? Now, if the biggest number is 100, you're not going to go up by what? 1. So even on this one, I mean, if you decide, you know what, I don't want to go up by 1s, I'm going to go up by 2s, then you better show me the numbers. So you can go up by anything you want to, but I better see what the numbers are. So does everybody understand what put the frequencies on the vertical scale means? Then it just says, draw the bar to a height that corresponds to the frequency. Now, do you see that on your first class? 9 and 5/10 was your lower boundary and 14 and 5/10 was your upper boundary. So that means from here to here represents class 1. What's the frequency for class 1?
8.
8. So when I draw the bar for class 1, it's got to go up to a height of 8. Well, the second class starts with 14 and 5/10 and ends with 19 and 5/10. What's class 2 got to go up to a height of what? 2. Then my third class goes up to a height of what? 10. And then my last class goes up to a height of
6.
There's your histogram. Now, technically, histograms, the bars touch. Don't those bars touch? Now, the bar graph we looked at a minute ago on CDC on the Mississippi Department of Health website didn't what? Didn't touch. All bar graphs aren't really histograms. Everybody with me? Histograms kind of a special kind. So you see why we didn't use the limits. Because if we'd used the limits, there'd have been a gap between this bar and what? And that bar. Because this one would have stopped at 14, then we'd have had to skip over and start at what? 15. Okay? Now, I'm going to tell you what's different about mine and the ones in the book. The ones in the book tend to shove this bar right up against that axis. And I think that's hard to read. Because if this thing's supposed to start with 95/10. So if I shove it up right there, this corner has 2 different values kind of at the same time. You see what I'm saying? It would be 95/10 for the horizontal and 0 for what? The vertical, and I think that freaks people out a bit. You can do that if you want to, but I'm always gonna kind of skip over a little bit. I just think that makes more sense to more people when you do that. But in the book, they're gonna jam it right up. So either way is right. I just think this makes it a little easier to read. Right? So does everybody feel comfortable making a histogram? Rachel? Yeah, I would label, in other words, if you're really making the graph, it would be something like ACT scores for Mississippi. Does that make sense? And it might be ACT scores down here and what? Frequency what? Okay. Okay, that's a very good question. All right, so does everybody feel okay then about making a histogram? All right, now let's talk about this. Let's talk about making a frequency polygon. Okay. All right. Making a frequency polygon. Making a frequency polygon. Now, when I say histogram, what two words pop in your head? Photograph. When you see frequency polygon, I want line graph. All right. Now, step one is going to be the same. You must have a frequency distribution table. All right. Must have a frequency distribution table. Now, what's different is this. This time, I want you to place the midpoints on the horizontal scale. So you're going to place the class midpoints on the horizontal scale. Okay. Place the class midpoints on the horizontal scale. Okay. And you know how to find midpoints, so you should be good to go there. Okay. This time you're still going to put the frequencies on the vertical scale. All right, put the frequencies on the vertical scale. What's that vertical scale got to start with? Now, same thing. Do you remember the day in class when I did the female salaries versus the male salaries? Remember when I chopped the graph off, how misleading that was, and I stretched it? That's the reason that vertical scale's got to start with 0. Because if you don't, you've distorted the meaning of the graph. Okay? So that's the reason it's got to start with 0 here and previously. Here's what you're going to do next. You're going to place a dot or a point. Let's put a point above each midpoint at a height that corresponds to its frequency. Okay. So you're gonna place a point or a dot, whichever makes more sense to you, above each midpoint at a height that corresponds to its frequency. Now, there are going to be 2 more steps, okay? So there's gonna be a step 5 and a step 6 that I'll let you fill in when we do this one real quick. Okay, go ahead and have them kind of written down there. So you gotta have a frequency table to start with. Then you've got to calculate the midpoints and put them on the horizontal scale. Then you got to put the frequencies on the vertical scale. So what have you got to go find right now that you don't know? Your what? Your midpoints? All right, so look at the one on the board. Isn't that the same class as I had before? What was the frequencies before? What was 10 to 14? That was the frequency of what was it?
8,
8. What was this one?
2,
2. Was it 10
10,
and 6?
6.
All right, we're going to make it the same. We're going to use the same table to make a frequency polygon. So step 1 is you have to have a table. Step 1 I've got. Step 2 is you have to have the midpoint. So you go real quick with your calculators and calculate those midpoints. What's my first midpoint? What number is halfway between 10 and 14? It's 12. What's the midpoint of this one? 17. What was the third one?
22,
22 and
27.
27. So those numbers have to be on this horizontal scale. So I've got a 12 and a 17 and a 22 and a 27. And again, like we talked about before, the width of the table was 5, and what do these midpoints also differ by? 5. They better match or you've made a mistake. So that's what step 2 means. Now step 3 is the same as it was before. What goes on the vertical scale? The what? The frequencies, right? And again, I've got to go at least to my highest, which was what? 10. Now again, if you want to go up by 2s or 1s, it doesn't matter. Just show me. Okay? So start with 0. Now, look what it says. Which class does 12 go with? That's the midpoint of which class? First one. What's the height? What's the frequency of that? 8. So when I put a dot above number 12, it's got to be at a height of 8 because 8 is the frequency. So that's what it means by put a point above the midpoint at a height that corresponds to its frequency. So where's the dot going to go above the 17 at a height of what? 2. And then above number 22, it's going to go to a height of what? 10. And then it's going to go to a height of what? So there's steps 1, 2, and 3. Now, step 4, put those dots. Now, let's look at step 5. What's a frequency polygon again? What kind of graph? What do you think I'm going to do to make it a line graph? Connect the dots. That's what step 5 is. All right, so step 5 is just connect the dots. Connect the points. Okay? So I'm literally just going to come over here and I'm going to connect those points. So in your notes, step 5 is to connect the dots. Connect the points. Now, step 6 is because of what they named it. They named it a frequency what? Polygon. Now, some of you I know, all right, a polygon's got 3 conditions on it. Remember what those conditions are. What's something to be a polygon? It's got to be, do you remember? It's got to be simple and what? Closed. And the sides have to be line segments. Well, simple means you can draw without picking up your pencil. And sure enough, I can draw that without picking up my pencil, so it's simple. Aren't these line segments? But the problem is, it's not what? It's not closed. So because of the way they named it, what you're gonna have to do is this. Your step 6 is, you're gonna have to connect these endpoints to this horizontal scale. So all I'm gonna do is literally just take and connect that endpoint to the horizontal scale, and I'm gonna connect that endpoint to the horizontal scale. Now it's closed. Okay? So step 6 is connect the endpoints to the horizontal scale. Yeah.
Should you draw a line straight down or?
That's a very good question. Here's what I'm not gonna fuss, okay? I'm not real particular. For whatever reason, the powers that be, when you try to figure out, should I drop it just straight down? What they tend to do is go halfway. If this width is 5, they'll go half that distance. Why? I do not know. I would love to tell you I knew why, but I don't. But as long as you just connect the endpoint to the horizontal, I'm happy. But that's what they're going to do. They always go about half the width and kind of drop it down to there. So that's what a frequency polygon. So in your notes, now you've got a histogram and a frequency polygon off the same table. Now, why would you want a histogram versus a frequency polygon? Well, do you see that frequency polygons are a little better to see trends over time? Histogram's really good to see highs and lows. Now you can see highs and lows here, but they're even more clear on a histogram. You see what I'm saying? But here I can see trends. In a second, I'll flip back to that MDE site and show you something. They've got a frequency polygon on that. I mean, choose that MDH site. Okay? So does everybody feel okay about histograms and frequency polygons? So when I say histogram, what pops in your head? Bar graph. When I say frequency polygon, what pops in your head? Line graph. The difference is what's on this horizontal scale. What goes on the histogram? The boundaries. What goes on the frequency polygon? The midpoint. So just get it straight in your head, which one goes where. Okay? Now we've got a third graph to go over, and it's something called a circle graph. Okay? Some people call it a pie chart, but mathematicians are going to call it a circle graph. Okay. Guess what step 1 is?
Have a frequency.
There we go. You got to have a frequency type. So making a circle graph. And I'm not going to say what comes in here when I say circle graph. Hopefully what goes in your head, the word what?
Circle.
Circle. Surely you don't have to say that. Okay. We're going to use the same table again. But now it's different. Okay. What you're going to do next on a circle graph is this. You need to total the frequencies. Now, what does total mean? What do I really mean? You're going to do what? Add them up. Okay. So look over here. You got your calculator. Go do that. So we're going to kind of write the steps down as we do them on this one. It seems less confusing. Okay. So I need you to get me a total. All right. What's my total?
26.
26. Okay. All right. 26. Now, what you're going to do is this. You're going to divide each frequency by that total. To get a decimal. All right, so you're going to divide each frequency by that total to get a decimal. So what am I about to divide over there? 8 divided by what? 26, right? Now, look, do that on your calculator. Do 8 divided by 26. Does that come out all pretty? No. So what we're going to do is, I'm going to put here, round to the hundredths, THS, if necessary. And you'll see why I'm doing that in a second. All right. Round to the hundredths, if necessary. Now, I didn't say round up. I just said rounds. Everybody with me? So you're just rounding off the way you normally round off. When did you round up previously? On what? On class with? Okay. Most of the time in here, you're going to round off. So do we understand that I'm going to have another column over here now, kind of for scratch work? It's going to say decimal. Now, when I took 8 and divided by 26, I get this number, and I'm going to write it and erase it. 0.30769230077. I got that big long number on my machine. Do we understand, first of all, this number doesn't really chop off here. The machine just ran out of space. But I told you to round it to the hundreds. Is everybody okay? Now, what column is the hundreds? How many numbers past the decimal to the right is the hundreds? 2. Now, I've got to know whether to leave that as 0 or whether to make it a 1. So I don't care about anything except the digit to the right. I ignore everything but the digit to the right. If that number is 5 or bigger, this number goes up. What happens if that number is 4 or smaller? What happens to that number? Stays the same. So is that going to stay a 0 or go to a 1? Go to a 1. So that's what I want to see. 0.31. Okay? So do that all the way down. Find me those decimal numbers. So I've got to divide 2 by the 26, and the 10 by the 26, and the 6 by the 26. And then I'll see if I agree with you. Make sure you bring those calculators every day. Because it's not going to do any good to write down what I get because I'm not going to be working your test for you. Okay? So 2 divided by 26. Did you get 0.07 or 0.08? What did y'all put?
108.
0.08. All right. What about the 10 divided by 26? What did y'all get? Point what?
38.
38. I agree. What about the last one? Point what? 2 what?
3.
3. Is everybody okay on that? Good? Okay. Now what you're going to do is you're going to change those percents to those decimals to percents. How do you change percents to decimals? Multiply by what number? 100. So you're going to multiply the decimals by 100 to get percents. Okay? So you're going to multiply the decimals by 100 to get percents. So now I'm going to have a percent column. Now, when you multiply by 100, what's that do to this decimal? It moves it what?
2 spaces up.
That's why I made you round to the hundreds. So you get whole number percents. So this is going to be 30 what? 1%. What's that going to be? 8%. This is going to be 38%, and that's going to be what? 23%. Now, here's a quick check. What should these add up to?
100.
About 100. Add them up and see if they add up to 100. Do they? Now, will they always add up to exactly 100? Why not?
With rounding.
Because you rounded. So sometimes you might get like a 99 or a 98 or 101. But if you get like 95 or 107, okay? So you want it to be exactly 100, but sometimes because you round, you get a little bit of error. But it should be close. Now here's the other thing you gotta have. You gotta have the angle measures. You gotta have angles. So you're gonna do something with these decimals to get angles. How many degrees, what kind of graph are we drawing? What kind of graph? Circle graph. All right, do you know how many degrees are in a circle?
360.
So what your step is going to be this. You're going to back up and you're going to multiply those same decimal numbers that you used before. But this time, instead of multiplying by 100, you're going to multiply by 360 to get angle measures. So you're going to multiply those same decimals by 360 to get the angle measures. Now, I'm going to let you round to whole numbers. I'm not saying you have to. I'm saying I'll let you round to whole numbers if you want to. Does everybody understand? I'm about to take this 0.31, this 31 hundredths. And what am I going to multiply by?
360.
360. Okay. Did you get 111.6? Now, you can look at it if you want to, but I'm just going to go to what degree measure? 100 what? 12. So you can round to whole numbers. If you'd rather leave it like that, that's fine. All right, what's 800.08 times 360 going to get?
29.
Because I get 28.8 on my machine, and I agree. If I round correctly, that's 29. Everybody okay? So 38 hundredths times 360. Now about 130 what? 7. And 23 hundredths, 0.23 times 360. You get about 82 or 83.
3.
Okay. So see if everybody got 112 degrees, 29 degrees, 137 degrees, and 83 degrees. Anybody got a question about where that came from? Now what we're going to do is we're going to go draw the graph. So there are your steps. And let's go draw the graph. So your last step is to draw the circle graph. So now that you've got that, your last step is you're going to draw the circle graph. Now, here's what I'm going to do. I'll give you a choice. You can go buy a protractor. A protractor is that thing that measures angles. Some people really are very precise people, and they already own a protractor. You know what I'm saying? So you are welcome to do that. If you don't want to do that, I will let you give me a rough sketch as long as it's reasonable. If it's not reasonable, I'm going to write you a note that says go to Big Lots or something. You see what I'm saying? All right. Now, what do I mean by reasonable? All right, here's what I mean by reasonable. First of all, what shape is the graph supposed to be? So draw a circle. Again, if you want to trace something or have a compass, that's fine. But as long as it's not crazy, I'll take it, you know. That's a pretty sad circle, but it suffices. Now, what's my first angle supposed to be over there? Measure what? 100 what? 12 degrees. Now, there are two things I expect everybody to know. What's 90 degrees look like?
Right angle.
It's a right angle, so it's like an L, right? So I would expect everybody to know that that would be about 90 degrees. And what are you trying to have? About 100 what? 12. So yours should be a little bit more, a little bit less than that. A little bit more. That's reasonable. Everybody with me? This would not be reasonable, and I would tell you to go to Walmart. Does everybody understand what I mean by reasonable? So there are two things I expect you to judge off of. 90 degrees is one of them, so that's how I had about 90, so mine was a little bit more than that. What's 180 look like? That's halfway, but straight across, right? Now, here's what you can do that I can't do. Now, some people probably can't even see this. See, you can have the angle drawn on your paper, and then you can turn your papers. Everybody with me? So my next angle starts with this one. Is everybody with me? But you can rotate your paper so this is now sitting over there to make it easy. I can't rotate the board. What's my next angle supposed to be? What measure? 20 what? 29. Now here's what I would do. This is over here. So do you understand that if I went like this, wouldn't that be about a right angle? That's about 90 degrees, right? What's 30 compared to 90?
1/3.
About a third. Is everybody with me? So in my mind, see, I'm kind of maybe about right there. Okay. Now, here's what needs to be kind of in the piece of pie. I want the classes. What class was this first one? It was the class 10 to what?
15,
14. What's this class?
15, 19.
15 to 19. Now, what's my next one supposed to be? 130 what? Sevens. Everybody with me? All right, so do we understand that if I went straight across, what would that be? Wouldn't that be 180? From here to wherever you're turning your paper around. If I went like that, wouldn't that be 90? In 137 between this one and this one, is everybody with me? That's reasonable for 137. What class is that? 20 to what? 24. What's my last one supposed to be about? 80 what? 83. Now here's where you have to kind of adjust. Does that look about 83? It doesn't, does it? That means this one probably needs to be a little bit wider. Is everybody with me? So I'm going to adjust it. Maybe that angle should have been a little bit wider. Now that looks more like 83. Is everybody with me? And that's my last class, 25 to 29. So that's what I mean by if you can draw a rough sketch without using a protractor, then you can do that. If that bothers you, just get a protractor for like $1 from Amazon or Walmart or wherever, and use your protractor. But that's what a circle graph looks like. Now, here's what you cannot do on a test. If I do not see your angle measures on your scratch work, I will not take your angles. You can't say, oh, I'm going to draw about 8% of the circle. You see what I'm saying? I'm not going to take that. So I need to see those angle measures in your scratch work for you to get full credit. Okay? And if it's way off, then I'll just put you a note that says you really need to go buy a protractor. And sometimes, to be honest with you, the protractor's quicker than trying to eye it. But that's completely up to you. Okay? So that's the 3 graphs you have to learn to do today. You have to learn a histogram. What 2 words pop in your head? Bar graph. What goes on the horizontal scale? You remember? Boundaries. You learned to make a frequency polygon. What 2 words you pop in your head? Line graph. Okay, what goes on the horizontal scale there? The midpoints. Then you learn to make a circle graph. Now, let me show you something real fast, maybe. See if it goes. Okay. You can't see very well, but these are little bar graphs. Everybody with me? Now, what they've done is they've superimposed a polygon on top of those here and here. So what they basically did was they went up here and made a frequency polygon out of this. They put the frequency polygon on top of the histograms. Everybody with me? The blue ones are the death, or the red ones are the deaths. The blues are the cases. And they got this. So do you understand that with this, you can see the trends a little better? Is everybody with me? Now, this is Mississippi's cases. This is April, May, June, July, August. Tell me something you notice. Why is it spiking in August? School. Now, this is a different kind of bar graph with conditions. Now, this one is the circle graph. And it's by race. So, the dark ones are blacks. These are whites. The red is American Indian. The pink are Asians. And the gold is other. And then it's got the percentages out there. Now, where did they get these percentages? Just like you got them on that table a second ago. Is everybody with me? So this one is COVID deaths by race. So which is the biggest piece of pie? Black is 49.2%. Though that's not the majority race in Mississippi. Okay? This is a pretty, now 1 6/10%, it doesn't seem like a lot, but there's a pretty good supply, I mean, there's a pretty good, percentage of American Indians, Native Americans in Mississippi. Is everybody with me? So when you start scrolling through this website, you get a lot of information. %86% of people with COVID did not go in the hospital in Mississippi. Almost 14% did. This one is a different kind of bar graph. It's not really a histogram, but it basically does two things. The top one goes by cases, and the bottom one goes by deaths. And it's color-coded again by race and by gender. Now, look at this one. These are who's getting it. Do you see that this is the biggest bar? Well, see, this is females, and this is black. So black females are getting it more in Mississippi than any other thing. In other states, some males are getting it more. You see what I'm saying? So this is just Mississippi. This isn't nationwide. So now statisticians have got to come back and suppose, why is that true? Why is that particular group of people getting it more often? So you need to think about that. Now look at the deaths. Even though the black females are getting COVID more than black males, what about the death rates? They're almost what? The same. All right. The male and female, it's the same thing. So you can look at it by race to kind of see kind of what's happening. You can look at it by gender to see what's happening. They do the same thing here. Again, this is COVID cases by gender. These are the females, these are the males. So in Mississippi, who's getting it more, females or males? Females are. All right? And there's speculation about why that would occur. But again, see, if I start giving you a list of numbers, do you see how you just kind of glaze over? But with graphs, you're automatically more engaged. All right? Now, on your homework, going to be? Homework's going to be where you're on? Moodle. Okay. I will see you next time.